Alright, let's work on this problem next. So this is LeetCode number 74, search in a 2D matrix. Write an efficient algorithm that searches for a value target in an m by n integer matrix. This matrix has the following properties. Integers in each row are sorted from left to right, and the integer of each row is greater than the last integer of the previous row. Okay. So this seems like almost like a 2D binary search would be appropriate. And this would be O of log m plus O of log n. So we need to we start by searching within, or start by performing essentially binary search on the first item of each column. And we want to find the largest value we want to find the column or the row with, and this should be row, not column. We want to find the row with the greatest value without going over. And the reason why we do this is that if we have a value that is under our target and the next row has a value that starts with the number that we want, or that is greater than the number that we want, then we know that it exists within the smaller row. Because of the fact that the first integer of each row is greater than the last integer of the previous row, right? So we will do that, and then, and of course, if no row is found, if no such row, then return false. Then next we can perform binary search on the row itself, and this can be done through collections, and we can just call it and return false if the resulting number is either greater than the value or greater than the size of the array or less than 0. That basically indicates that it does not exist within our matrix. And yeah, so this is log m because we need to do a binary search essentially on the first number of each row. And then we need to do log n, which is the binary search within any individual row itself. Let's get started with this. So the first step is doing the binary search on each column, or each first value of every row. So val middle column is equal to, let's do a search row, which will take in our matrix, which is an array of integer arrays, a target, which is an integer, left, which is an integer, and a right, which isn't, or we can say up and down. And this returns an integer. And we'll say val middle column, or middle row, sorry, is equal to up plus down divided by matrix dot size. Actually divided by 2, sorry. And then we can say if middle dot row, or let's see. Matrix at, and this is in, matrix is in, I think it's row column order. So if we want the middle row at 0 is equal to our target, then return our middle row. And we can do a when statement actually here. We can essentially copy most of this. And we can do this as a return when. If our matrix at middle row at 0 is less than our target, then we want to return search row at matrix target. If our row has a value that's less, let's see. Well, we want to say if matrix at middle row at 0, or sorry, middle row plus 1 is less than matrix dot size, and this value is greater than our target, then we want to return our middle row. So this is the idea that if our value is less than the target, but the next row starts with the value that is greater than our target, then we will search this row. Otherwise, if middle row plus 1 is greater than or equal to matrix dot size, we want to return -1, because that means that we've our last row is less. Well, actually, no. If this is the case, that we're at the last row and it's less, then we want to also return middle row plus 1 is greater than or equal to matrix dot size. Because the idea is that then we can just search the last row, and if it doesn't exist there, then we know for sure that it doesn't exist within the matrix. So those are the two cases where we want to return our middle row. Otherwise, we want to return our search row at matrix with our target with our now index at middle row plus 1 for our up matrix, and our down still at down. If our matrix at middle row, and this should be an else statement. So if our current item is larger, then we want to check if middle row -1 is greater than or equal to 0, and our matrix at middle row so this is greater than 0, sorry. At 0 is less than target. If our previous row has a value that's less than our target and our current is greater, then we want to return middle row -1. Otherwise, we want to, if middle row -1 is exactly, or let's see, -1 is like that, is less than 0, then we want to return our current row. Actually, if our current value is greater, If our starting value is greater, then we return -1. So if the value that we start with is greater than our target, and we are at the first row, so return -1 if we are at the first number in the matrix and still larger than target, because then we know that it cannot exist within the matrix. The same cannot be said about this one, because we are only searching the first value within the matrix and not the last value within the matrix. So it could be potentially within our row, we just haven't found it yet. But in this case, since we're searching the first one, we know for sure that it cannot exist within there. Let's see. Otherwise, if that's not the case, then we can also return search row matrix targets up and middle row. So this will be exclusive. Searches for the proper row in the matrix, inclusive of up and exclusive of down. So let's see. If we found the value exactly, then we can return the middle row. And if we're under the target, we check the next value if the next value exists. If the next value exists and is larger, then we know that we're in the correct row. Or if we're in the last row, then we know that it could exist still within our row. Otherwise, in that case, if the next value is also less than our target, then we know that we have more rows that we can search, or more first values within the row that we can search, and we continue. The same thing goes here, that if our current value is greater, if we have a previous value that exists, and it's less, then we know that that row is going to be our next, or the row that we want, right? Because our current value is greater, then that is the first row in which the value starts with something that is less. So it must exist within that row. If our current row is 0, then we have no more previous rows to search through, and our value is still greater, so we can just discard the entire search entirely. Otherwise, if the previous row is still greater, then we will recurse on that half of the matrix rows using the previous up value and our current middle value as the right edge, which is exclusive. So now we can say that our middle column, or our middle row rather, search row, will be our matrix. Our target will remain the same. Our up value will be 0, and our down value, our bottom value, will be our matrix dot size. Again, because this is exclusive. And then we can just return row really quickly. And let's see if this works as we expect. Actually, no. We can print line the row and just return false, just so we get a sense of whether or not it's working. So this is doing a Stack Overflow. Let's see. Matrix. Well, if up is greater than down, we want to return -1 as well. And this is the same thing as, I believe, just the standard binary search thing. Could have gotten it wrong, though. Let's see where we're ending. Let's see where we're... row at matrix middle row 0. And let's see where we're getting stuck for example 1. We should be getting 10 for the first one. Then we should recurse on the bottom. On the bottom row, and this should be 1. And since this 1 is less, then we know that let's see. Okay, so we get row 1 value 10, and then let's see. Then I wonder if it's just not quite. If the Kotlin compiler is just getting a little bit confused about sort of how we're dealing with this. Yeah, okay. So now we go to, so that seems to be working. That seems to go to the proper row. Then we can say val index of, well, we can say first if matrix at row 0 is equal to target, then we can return true. So this is just a sort of quick edge case. Then we can do val index is equal to matrix at row dot find. I believe it's find. Let's see, int array. And we want to do find. Or is it index of? Search, maybe? Binary search, there we go. We want a binary search for the target. And then we want to say if return index less than 0 or is greater than or equal to 0 and index less than matrix row dot size. Cool. Let's do second. So this just runs a binary search on this, and if it doesn't exist within the matrix, then it should return the standard a negative value if it exists before, or if it exists within somewhere else, and then if it's over, then it'll return the size. I think I believe there's better documentation here of exactly, yeah, the insertion point, which could be up to the size. Anyways, looks like we got an array out of bounds exception on line 36, really. We did -1. Oh, okay. If row is less than 0 or row is greater than or equal to matrix dot size, we return false. So if we could not find a suitable row to search, return immediately. This is in case we get lucky. And then otherwise, continue searching the row itself. So this should not, so if it's less than 0, then we know that we screwed up somewhere and we couldn't find it. And if it's at the size, then we also know that we screwed up somewhere. And so this should now work, because we know for sure that if it doesn't work, If we do some overlap here, then it'll return -1, and then here we'll pick up on that. And we won't continue with our algorithm on an invalid row. Looks like this is a pretty standard solution. I'm happy with it. 2D binary search, pretty standard stuff. In any case, I hope you learned something, and I'll see you for the next problem.